Let's take another example on frame attachments and DH parameters. So this example here, we need to assign frames 0 to 4 for the shown planar 3R robotic manipulator. Then find the DH parameters table. So, whenever we say 3R, that means 3 revolute joints. So sometimes we call it 3R or RRR. And when it's a planar, that means all 3 joints are in the same plane. So this is how 3R robot looks like. We have joint 1 and joint 2 and joint 3, all of them revolute joints. This is theta 1 and theta 2 and theta 3. This is L1, L2, and L3. And this is the end effector where frame 4 will go. Or typically we call it frame N or frame E for end effector and so forth. Okay, so we need to find the frame assignments, assign frames, and find the DH parameters for this example. To start solving this problem, we're going to look here at the robot. And the way I'm going to start this is I'm going to start with assigning z-axes for joints 1, 2, and 3 first, and then go back to assigning the z-axis for frame 0, and then the z-axis for frame 4. Okay, and then once I have the z-axes all assigned, then it will be easier for me to assign x-axes. They will go from z to z. So since I already have the z's, I can just go ahead and start doing the x's. And I'll again start with x1 and then x2 and then x3, and then I'll go back down to x0 and then to x4, since these are special cases. And then once I assign the z's and x's, then I'll go back and assign the y's. And for the y's, we're going to just use the right-hand rule, so we're going to start right from frame 0 upwards. So to start here with the z's, I'm going to start with z1. Z1 is, of course, the axis of motion for joint 1. Since it's a revolute joint, it's rotating about at the axis that's either coming out of the screen or going into the screen. So we have an option to choose either direction. Both of the directions are correct as long as we are consistent in calculating this in our DH parameters. So for Z1, I'm going to assume that it's coming out of the screen, and I'll assign right at this point. So this is my Z1. And just for notation, again, I will put a circle like this to indicate that this axis is out of the screen, and an X if the axis is going into the screen. Okay, so that's my Z1 right here. Now going on to Z2, again, I have a revolute joint, and it's rotating about the axis that we see here at this dot. So the axis of motion is the axis that's either going into the screen or out of the screen. In this case, I'm going to choose the axis for Z2 as coming out of the screen so that it's consistent with Z1, and that would eliminate any possible alphas. If I choose this to be going into the screen, that would make alpha 1 180 degrees, and that would mean more calculations. It doesn't mean that it's wrong. It would still be right, but it's easier for me to have less calculations and then have this axis for Z2 coming out of the screen. Okay, so I'm gonna put this circle here. I'm gonna call it Z2, and this is the axis for frame 2 that's coming out of the screen. Going on to Z3, again we have a revolute joint here, and that joint moves about this axis where the dot is. And again, for consistency and so that I can eliminate any possible twist angles, I'm going to assume that this axis for Z3 is coming out of the screen. Although if I put it into the screen, it would still be a correct answer as long as I count that twist angle to be 180 degrees. But if I want the twist angle to be 0 degrees, then I'll have it coming out of the screen on this dot. So I'm going to assign this out to the screen. We'll call it Z3. Okay. Now I'm ready to go back to frame 0, which is the ground frame. And as we said earlier, it's always good to assign the ground frame at the same position and orientation as frame 1 when the joint angle is 0. Okay, so this is joint angle 1. Since Z is coming out of the screen, Z1, for the first joint, I'm going to assume that Z0 is also coming out of the screen at the same location. So both Z0 and Z1 would be the same line. So I'm going to just add Z0 here. Okay, so this circle here represents Z0 and Z1. All right, and then for the last frame, frame 4, I can assign this arbitrarily, but because I would like the twist angle to go to 0, that means I can assign Z4 to be the same direction as Z3 at this location. Okay, so it will be coming out of the screen, and it will, because remember there's no revolute joint or any joint here, so assigning this axis can be arbitrary, but I'll assign the Z similar direction to Z3 so that I will eliminate the twist angle. So I'm going to put here Z4, and that circle indicates that it's coming out of the screen. Okay, so now we are done with the Z axes. I'm going to go ahead and eliminate these theta 1, theta 2, theta 3 indicators, just so that I can have a clean plot here to start working on the X axis and Y axis. So I'll just eliminate these. We already know that these are thetas. Okay. Now I'm going to start with X1. X1 is along the common perpendicular between Z1 and Z2. This is Z1 coming out of the screen. This is Z2 coming out of the screen. The common perpendicular is the line that's perpendicular to both of these, Z1 and Z2, which is the line that goes through this link. Okay, that makes this point the origin of my frame 1, and then X1 will have to be going in the direction towards Z2. Okay, so if I draw this, I'll have X1 going from the origin of frame 1 along the common perpendicular between Z1 and Z2 towards the direction of Z2. Okay, now we're going to go on with X2. X2 is the common perpendicular between Z2 and Z3. Now Z2 is coming out of the screen, Z3 is coming out of the screen. The common perpendicular line is the line that goes through both of these Z2 and Z3 and perpendicular to both of them. Okay, so that makes this point the origin of my frame 2. That's the point of intersection between Z2 and the common perpendicular between Z2 and Z3. Okay, so my X2 would be initiating from the origin of frame 2 and going towards Z3 along the common perpendicular. So I'm going to draw that. This is X2 initiating from the origin of frame 2 along the common perpendicular between Z2 and Z3 and pointing towards Z3. Okay, now for X3, I'm going to look at Z3 and Z4. I'm going to identify the common perpendicular between Z3 and Z4. Z3 is coming out of the screen, Z4 is coming out of the screen. The common perpendicular is the line between them along this here. And that means that the origin of frame 3 would be right at this point, which is the intersection between Z3 and the common perpendicular between Z3 and Z4. Okay, so this means I'm going to have to start my axis of Z3 at the origin of frame 3 and going towards Z4 along the common perpendicular. Okay, so that's my X3 axis, starting from the origin of frame 3 and going towards Z4 along the common perpendicular between Z3 and Z4. All right, now I'm going to go down to frame 0. So I'm going to assign X0. Remember, again, for the ground frame, I would like to assign frame 0 to be similar to frame 1 when the angle is 0, when that joint here is 0. Okay, so when this joint is 0, we imagine this link would be all the way down here. Okay, so basically X1 would be right here. So I'm going to assign my X0 to be starting at right here at this point and then going this direction, which is the direction where whenever X1 or joint 1 is 0, that would be the location for it. Okay, and again, this could be arbitrary, but you know, when we do it this way, we save ourselves some calculations and make it easier for frame assignments. So I'm going to go ahead and do the X0 here, starting from frame 0 origin and going into the right direction. And then that means this is the angle of theta 1 between x0 and x1. Whenever theta 1 moves, x1 moves along with theta 1. Now going to x4, as we said earlier, it's always good to assign frame 4 so that, or frame n, so that we can cause as many dh parameters as possible to go down to 0. Okay, so I can assign x4 at any direction and anywhere, but since I have x3 heading towards this direction, if I assign x4 to be heading the same direction and starting from here, that would eliminate a theta angle in my dh parameters. Okay, so I'm going to start it here, so that would make the origin of my frame 4, which is the point of interest at the end effector that I'd like to know the kinematics based on of. And then it will be pointing out this way, which is the same direction as x3. Okay, so as you can see here, this is my x4. Now I'm done with my z-axis and x-axis. I'm ready to go ahead and assign the y-axis using the right-hand rule. I'm going to start with y0. My z0 here is coming out of the screen, so I'm going to put my thumb out of the screen, the same direction as z0, and my 4 fingers would be going towards x0, and then I move my 4 fingers by 90 degrees, and that would mark the direction for y0. Okay, so if I do that, y0 would be coming up this way. And remember, this is straight up, it does not match with x1. This is y0, which is 90 degrees from x0 and 90 degrees from z0 as well. Okay, now going on to y1, again I'm gonna put my thumb towards z1, which is coming out of the screen, and then my 4 fingers towards x1, and then I'll move my 4 fingers by 90 degrees, and that would give me the direction for y1, which would be this direction right here, along this line where we're looking at L1. Okay, so I plot this, and that would give me the direction for y1. For y2, again, I'll be pointing my thumb towards z2. z2 is coming out of the screen, so my thumb is coming out of the screen. And then my 4 fingers are pointing towards x2, this direction. Now if I move my 4 fingers by 90 degrees, that would take me in this direction, and that would be the direction for y2. So I'm going to go ahead and draw it. That would be my y2. Coming to y3, again my thumb is going out of the screen towards z3. My 4 fingers are going towards x3 in this direction. If I move my 4 fingers by 90 degrees, I'll get the y direction somewhere around along this direction here. So I'm going to go ahead and draw it. This is the direction for my y3. Now this is a common mistake. Remember that this line has nothing to do with this dotted line that's marking the link for L2. Okay, this line here is exactly 90 degrees from x3, and also exactly 90 degrees from z3, which is coming out of the screen. Okay, so you don't have to follow any specific line and think that this is, it makes sense to put it this way. All right, because remember, this is a joint. Whenever the joint moves, the perspective of where x3 relative to this line would be changing. So y3 is always 90 degrees with x3. So we have to make sure that we do this in perspective. As you can tell here, this line is the same as this line, which will be the line that we're looking at for L3, for this link. Okay, now going on to y4. Again, the same thing. I'm going to put my thumb towards z4, which is coming out of the screen, and then my 4 fingers towards x4, and then moving my 4 fingers by 90 degrees. That gives me this direction for y4. I'm going to go ahead and draw it. So that would be my y4 for frame 4. Okay, I went ahead here and summarized all the axes that are not clear, that are going either towards into the screen or out of the screen. So X is for any axes that are going into the screen. In this example, we don't have any. And then that circle is for axes that are coming out of the screen. For this example, we have 0, Z0, Z1, Z2, Z3, and Z4. All of these axes are coming out of the screen. All right, now I'm ready to go ahead and start filling out the DH parameters table. So I'm going to put this quick reference as a reference to quickly look at how we can, extract the DH parameters, A, alpha, and D, and theta. And I put here a table where we can also fill out for these parameters for each link and joint pair. So when I equals to 1, that means we're going to be filling joint pair parameters or DH parameters for the joint pair of joint and link 1 right here. And then when I equals to 2, I'll be filling out the parameters for joint and link pairs number 2. And then when I equals 3, that means I'm filling out the parameters, the DH parameters for link 3 and joint 3. And then when I equals 4, that means I'm going to fill out the DH parameters for the pair of joint 4. There's no joint 4, but frame 4 and link 4. Okay, there's no link 4 either, but we're talking about frame 4. Okay, so we're ready now. So we're going to start here when I equals to 1. I'm going to be looking at alpha I minus 1. That means alpha 0. This is the chart for alpha. So when I'm looking for alpha 0, I should be looking at Z0 and Z1 about X0. Okay, Z0 is right here coming out of the screen, and Z1 is right here also coming out of the screen. And the angle between them about X0, which is this axis right here, obviously it's 0 since both Z1 and Z0 and Z1 are the same line. Okay, so that means my alpha 0 is 0. Now when I equals to 2, that means I'm going to be looking at alpha I minus 1, that means alpha 1. Looking back at this chart, if I want to find alpha 1, I should be looking at Z1 and Z2 about X1. Okay, Z1 is right here coming out of the screen. Z2 is right here coming out of the screen. And I'm going to be looking at the angle between them about X1. This is X1. Okay, so the angle between them obviously is 0 since both of them are coming out of the screen. Okay, so that means I can fill this for alpha 1 to be 0. Now when I equals to 3, I'm going to be looking at alpha I minus 1, which is alpha 2. For alpha 2 here, I'm going to be looking at Z2 and Z3 about X2. This is Z2 coming out of the screen, Z3 coming out of the screen. I'm going to be looking at the angle between them about X2. Obviously, both of these lines, Z2 and Z3, are heading to the same direction. So the angle between them about X2 is 0. So I'm going to put here for alpha 2 equals to 0. Now when I equals to 4, that means I'm looking at alpha I minus 1. That's alpha 3. So for alpha 3, I'll be looking at Z3 and Z4 about X3. This is Z3 coming out of the screen. This is Z4 coming out of the screen. I'm looking at the angle between them about X3. Again, obviously Z3 and Z4 are heading to the same direction. So the angle between them about X3 would be 0. That means my alpha 3 here is 0. Okay, and that finishes the alpha column for this DH parameters table. Now we move on to the A column of the DH parameters table. So when I equals to 1, I'm looking at AI minus 1, that would be A0. This is the chart for A. So if I'm looking at A0, I should be looking at Z0 and Z1 about X0. Okay, Z0 is right here, Z1 is right here. I'm looking at the distance between them along X0. This is X0. So obviously Z0 and Z1 are the same line. So the distance between them along X0 is 0. That means A0 here equals to 0. Okay. Now when I equals to 2, that means I'm looking at AI minus 1, that's A1. So I look here again, A1, I should be looking at Z1 and Z2 about X1. Z1 is right here coming out of the screen. Z2 is right here, coming out of the screen. I'm looking at the distance between them along x1. This is x1. Obviously, there's a distance between Z1 and Z2 along x1, this x1 line. And that distance, we can see it right here. That's L1. Okay? So that means A1 would be L1. And again, I don't want you to associate L1 to be always associated with A1. This here can be whatever number or name, doesn't matter. It just happened here to have that L1 and it matches what we have for A1. But that's not necessarily common in all the examples. Now when I equals to 3, I'll be looking at AI minus 1, that would be A2. So for A2, I'll be looking at Z2 and Z3 along X2. This is Z2 coming out of the screen. This is Z3 coming out of the screen. And the distance between them along X2, this is X2, okay? Obviously, the distance between them along X2 has a value here, and this value is L2, okay? So that means A2 equals to L2. All right, when I equals to 4, I'll be looking at AI minus 1, that would be A3. For A3 here, I'll be looking at Z3 and Z4 along X3. Okay, this is Z3 coming out of the screen. This is Z4 coming out of the screen. And I'm looking at the distance between them along X3, this direction here. Okay, obviously the distance between Z3 and Z4 is right here. That's L3. So that means A3 is equal to L3. Okay, that completes my second column here for the joint length A. Now we move on to D, which is the joint offset. I'm sorry, A is the link length, and now we move on to the joint offset. So when I equals to 1, I'll be looking at DI, which is D1. This is the chart for D1. So when I'm looking for D1, I'll be looking at X0 and X1 along Z1. This is X0 and this is X1. I'm looking at the distance between them along Z1, which is coming out of the screen right here. Obviously, both of these lines, X0 and X1, they both intersect at Z1. So that means the distance between them along Z1 would be 0. Okay? So that means D1 is 0. Now when I equals to 2, I'll be looking at DI, which is D2. So from this chart, if I'm going to find D2, I have to look at X1 and X2 along Z2. Okay? X1 is right here, and X2 is right here. And I'm going to be looking at the distance between them along Z2, which is coming out of the screen right here. Okay? So obviously this line, if you extend this line, it will intersect with this line. So both X1 and X2 are intersecting right where Z2 is. Okay? That means the distance between them along Z2 would be 0. Okay? This means that D2 equals to 0, and that's what I'm going to indicate here. And then when I equals to 3, I'll be looking at DI, which is D3. So for D3, I should be looking at X2 and X3 along Z3. This is X2, and this is X3. And I'm looking at the distance between them along Z3, which is coming out of the screen. Obviously, X2 and X3 intersect right at this point where Z3 is, which means the distance between X2 and X3 along Z3 is 0. Okay, so that means D3 would be 0. Now when I equals to 4, I'm looking at DI, which is D4. Again, from this chart, if I want to see D4, I have to look at X3 and X4 along Z4. This is X3 and this is X4. I want to find the distance between them along Z4, which is coming out of the screen. Okay, obviously these two lines are the same line. Okay, So the distance between them along Z4 would be 0. That means D4 would be 0. Okay? Now, remember the first two parameters, the link parameters here, are always constants. So all of these numbers are constants. And then between these two link parameters, joint parameters, the D and theta, these are joint parameters. Between the two of them, one of them would be constant and the other one would be variable. Okay? So in this case, since all of them are revolute joints, that means the D would be constant. Okay? And the theta would be variable. If we had any prismatic joint, then the D for that prismatic joint would be a variable and the theta would be constant. And constant does not necessarily mean equals to 0. It can be any number that's constant, not necessarily 0. Now let's move on to theta. When I equals to 1, I'll be looking at theta I. So that would be theta 1. This is the chart for theta. So for theta 1, I'll be looking at x0 and x1 about z1. This is x0 and this is x1, and the angle between them about z1, which is coming out the screen here. Okay, obviously the way it looks right now, there's an angle, but remember this angle changes every time that joint 1 moves. Okay, x0 is attached to the ground, so it doesn't move, and x1 is attached to link 1. So whenever joint 1 moves, x1 moves along with link 1. Okay, so x1 is always swinging back and forth and changing the angle between x1 and x0 as the theta moves. Okay, so that means the angle between x0 and x1 about z1 is a variable, and that variable is theta 1, which is the value for the first joint. So I'm going to put here theta 1. Now when I equals to 2, I'm looking at theta I, which is theta 2. Again, from here, I'll be looking at x1 and x2 about z2. Okay, this is x1 and this is x2, and I'm looking at this distance about z2. This is z2 coming out of the screen. So obviously if you extend this x1 line, it's going to come all the way up to here. Okay, and as soon as I start moving joint 2, this x2 will start moving back and forth. Okay, so that would change the angle between x2 and x1. So this means that the angle is not constant and it's a variable, and that variable is the joint value for joint 2, which is theta 2. So I'm going to put here this as a variable theta 2. Now when I equals to 3, I'll be looking at theta I, which is theta 3. So from here again, for theta 3, I'll be looking at x2 and x3 about z3. This is x2 and this is x3, and I'm looking at the angle between them about z3, which is coming out the screen right here. Okay, now again, if you extend this line here, it will come somewhere right here, and obviously there's an angle between x2 and x3, and that angle changes as we move that joint 3 right and left. Okay, so when we move joint 3, x3 will start moving as well, and that would change the angle between x3 and x2. So this means that this is a variable parameter. So we'll put, which is at the value of theta 3 for joint 3. So I'm going to put here theta 3 for that parameter. Now, when I equals to 4, I'm looking at theta I, which is theta 4. So for theta 4, I should be looking at x3 and x4 about z4. This is x3 and this is x4. And I'm looking at the angle between them about z4, which is right here coming out of the screen. Okay, now obviously there's no joint here. So if there's no joint, the angle between x3 and x4 will never change since there is no joint. Okay, so that would be a constant. And that constant, obviously, if you see it right here, that has the exact same direction, which means that theta here in this case would be 0. Okay. Now, if I put x4, since this is the end effector here, it doesn't have a joint, so I can put x4 in any direction. If I put x4, for example, in the direction right here where you see y, that would give me an angle here of 90 degrees, which I don't like because that means I'm going to have to do more calculations down the road when I do the forward kinematics. Okay, so that's why when I put it in the same direction as x3, when I assign the frames, that eliminated that theta that would have gone here. Okay, so now since x3 and x4 are the same direction about z4, that means theta 4 would be 0. Okay, and that completes the DH parameters assignment and also the frame assignments.